Okay, welcome everyone. Ms. Dorothy Speck with our Cultural Affairs Division.
Good evening, everybody, and welcome to the first of our lecture series this semester. We have 6 scheduled so far, and they range from this evening on psychedelics to stream conservation to highway construction. There's a big variety. So please make sure that you check out our website, www.sunyorange.edu/cultural affairs, to keep up on all the offerings. We also have master classes, and I also want to point out that next Wednesday at the same time at 6:30, Penn State Professor Kathleen Cahill will be speaking on Who Was a Suffragist? A More Diverse Look. So that's rather apropos since voting is very important. We're having a national election, and we have just celebrated the 100th anniversary of the ratification of the 19th Amendment. So that is a week from today at the same time. And we're really pleased to have Dr. Slish back this year. He's been here before speaking on the medicinal and recreational marijuana, cannabis, as well as opiate addiction. But I would like at this point to turn the program over to Professor Dr. Shelley Paradis, who actually went to high school with Dr. Slish, and she will give the introduction. Thank you very much.
Thank you, Dorothy. And Don, it's so nice to see you, even virtually. I could go through Don's very impressive credentials, but I know you've all had a chance to look at those. I'm going to talk about something a little more personal about Don, and that I have had the pleasure of now, whoops, something happened with my video. I've had the pleasure now for the second time to have a student in common with Professor Slish. And both times, the students speak so highly of Professor Slish, not just how competent he is, but also what a caring and dedicated professional he has been in their educational process. So, and I think I've said this on one other occasion when Don was here to speak. Don was one of the first people to reach out to me when I was hired here at SUNY Orange 20 years ago. It's hard to believe it's been that long. He reached out to me and was like, hey, SUNY Orange or SUNY colleague, it's nice to see your name on the list. So, you know, it's amazing at this point in our lives, because we're going to celebrate our 40th year out of high school. I hate to admit that a little bit, but you know,
and I'm only 35, so.
I know, we were embryos at the time. But it's really just such a pleasure to know Don now as a professional and to still be in touch after all of these years. So Don, thank you so much for being back with us. I'm really I'm interested in this topic. It's something that I've followed for probably the last 15 years. So I'm really excited to hear what you have to say about it. And
okay.
Thanks again for joining us.
Thanks. Well, I don't know if I should give my talk now, because I don't think I can live up to that introduction. That was pretty amazing. Thank you so much. So I really feel bad that I can't be there. I enjoyed so much being there the last 2 times, and the crowd there is always wonderful. Hopefully you guys, anytime you want to stop me during the talk, go ahead and stop me and ask me a question. So I'm just going to go ahead and jump into it here.
While Dr. Slish is sharing his slides, for all of our attendees, please do use the Q&A. We are monitoring, and we will be posing questions to Dr. Slish throughout.
Okay, so can you see these slides? We're good?
Yes, we can, Doctor.
Okay, good. All right. So what is a psychedelic? So I teach this class called Introduction to, Pharmacology of Recreational Drugs. And one of the sections of my textbook is psychedelics. And there are 4 different classes of hallucinogens. And one of those classes is psychedelics. And the psychedelics then are drugs whose primary action is to alter cognition. So you can contrast that to things like cocaine or alcohol, where it's all about mood and making you feel good. This is more about making you think differently. And the word psychedelic comes from the word soul manifesting or mind revealing. And we'll see how that's really important in the therapeutic use of these, that soul manifesting aspect to them. And if you're as old as me and Dr. Urban, I'm sorry, Paradies, we remember the 60s a little bit. We were too young to actually participate in this, but this is what we always think about when you think of psychedelics, the 60s. Tune in, turn on, tune in, and drop out. Just happy people having fun watching different colors flash on the screen. This was another aspect of the 60s and 70s. I'm not going to jump, I'm going to fly. Kind of with psychedelics, sometimes people lose their sense of reality and they get themselves in trouble. And this is like pretty much the biggest side effect to psychedelics is if you're not careful, you don't have a guide there to help you and make sure you don't mess up, you can really hurt yourself. So that's why, I am in favor of this being used therapeutically, but I wouldn't experiment with it myself. Okay. So at the end of the 60s came the 70s, and in 1971, Richard Nixon got this Controlled Substances Act passed, and it made all psychedelics Schedule I drugs. Schedule I means it can't be used for anything, not for research, not for any experimentation or anything, cannot be used. So at that point, from the 50s through the 60s, there was a lot of research on psychedelics to see if they can be used for psychological studies. And then once this act was passed, no more research was done until the 2000s. So we lost a lot of ground because of this. The 3 drugs I always talk about, the 3 main psychedelics are LSD, psilocybin, and DMT. So LSD came from ergot alkaloids. Ergot is a fungus that grows on wheat. And there are funguses like mushrooms. Mushrooms are a fungus. So funguses make a lot of different crazy chemicals. And most of them are not harmful, but every now and then there's some that are pretty psychoactive. And so back then they used ergot alkaloids for blood to stop not menstrual flow, but postpartum bleeding. It was used because of contracted vessels. So they took that structure of the ergot and changed it 100 different ways to see what they could make out of that drug. One of them was this, and Hoffman accidentally took it, and he's riding his bike, and suddenly the whole world shifted. It was just, whoa, this is something crazy. So that's where LSD comes from. Psilocybin has been used traditionally for hundreds, probably thousands of years. It's a mushroom, grows in Mexico in the Southwest. Well, actually, the mushroom makes the psilocybin. And then DMT. DMT is a chemical it's found in your brain, and it's also found in certain plants. The Psychotropa viridis is one of those. The thing about DMT is it's got a really, really short half-life. We'll see that in a second on a later slide. But it'll last about a half an hour. But, hundreds of years of experimentation, people figured out if you mix this plant with another plant, the other plant makes this plant last longer. Turns out the other plant was blocking the metabolism of this one. So this ayahuasca is a blend of different plants, and the active ingredient is DMT, but some of the other things make the DMT last longer. Biggest difference between these different psychedelics is not their effect. They all do the exact same thing. The biggest difference is the pharmacokinetics. So LSD is extremely potent. 100 micrograms is a strong dose. Whereas here, psilocybin, 20 milligrams and 50 milligrams from DMT. So this is 200 times higher dose to get the same effect. So LSD is extremely potent. Takes a long time to come on. A lot of people get themselves in trouble with drugs like this because they'll take the drug and an hour later nothing's happened, so they'll take another one. And then the first one kicks in, and an hour later, the second one kicks in. So slow onset drugs are kind of dangerous for this. And LSD, of the three, lasts the longest. It lasts about 8 to 12 hours. Psilocybin, again, lasts a lot shorter. And that's why typically this is the one that's used in drug studies. And then DMT, again, onset in 5 minutes, lasts for 30 minutes. So very short. And that's for like a nasal insufflation. You snort the DMT, that's about how long it'll last. They used to call it the businessman's high because you could do it at lunch and then it'd be over before lunch was over. Ayahuasca then is similar to LSD in duration. So it lasts a lot longer than the DMT by itself. Hang on, let me check something. Okay. So what is the LSD trip like, the psychedelic trip like? I have to be honest with you, I've never experienced this. This is what I've only read about this, but just to let you know, at first there's the onset where you start getting the visual hallucinations. They say the walls start to breathe, the walls move in and out. And then geometric patterns appear and objects change shape. A lot of this is because the drugs are directly stimulating your occipital lobe. So your occipital lobe gets all this stimulation, it's making colors and lights and stuff, and the rest of your brain takes all that and turns it into something. So that's where your hallucinations are coming from. And by the way, the hallucinations have nothing to do with the spiritual effect or the therapeutic effect of the drug. They're just crazy sideline. Plateau. So okay, so then once you peak, you go up, you plateau, and this is when subjective time slows down and the visual effects will intensify. And then you get this synesthesia, which is a crossing over of senses. And people describe it as seeing sound coming at you. I talked to a friend who said he dropped acid at a Grateful Dead concert. He could see the sound coming from the stage towards him. So that's synesthesia, crossing over of senses. And at this point, the user starts to lose control of what's going on. And that's where it can become scary. If you're afraid of losing control, a lot of people will have a bad trip at this point because you're not in control anymore. And then the peak experience then. After the plateau, there's the peak. And the peak is depersonalization, which basically means you don't know who you are and you're not connected to yourself anymore. You're separate from yourself. It's like being out of your body. And this is where this spiritual awakening happens during the trip. And typically you've got a lot of self-reflection, and this is probably the most important part of the drug in terms of therapeutics. So we'll talk about this later and how this works into using the drug therapeutically. And then eventually the drug runs out and you have the come down and the effects slowly start to recede. Okay, so how does this work? Why does this work? We need to talk a little bit about the brain structure and brain chemistry to explain how this works. In your brain, you've got two main neurotransmitters, glutamate and GABA. And these two do 90% of everything in your brain. Glutamate is the excitatory, GABA the inhibitory, and they kind of fight each other, and that's how most things are going on in your brain. But then you've got all these other neurotransmitters, probably hundreds of them, and they modulate the glutamate and GABA. So they're affecting the glutamate and GABA to kind of fine tune and make things a little more complicated. So this is just some of them. These are the ones that I usually talk about: acetylcholine, dopamine, which is important in addiction. We'll talk about that a bit today. Norepinephrine, which is about excitement, waking you up and being excited. Your stimulants cause the release of this. And then serotonin, which is our big one today. Mainly we'll be talking about serotonin. And then you've got other ones like endorphins and enkephalins, which are the endogenous opiates. And all of these things, what they're doing is modulating the glutamate and GABA activity. So serotonin, what does it do? It regulates your mood, regulates your memory, and your sleep and cognition. So I actually just teaching about this in class this week. I said it's kind of like it makes you happy. It's like your mood elevator, makes you feel good about yourself. That's what serotonin is. So psychedelics then, here's the structure of serotonin. And I know most of you don't know a lot of organic chemistry, and that's fine. So I kind of outlined this part of the structure of serotonin. And if you look, you've got a very similar thing in all these other drugs. So you can tell that these are going to fit into the same receptor as serotonin does, and that's how they work. They bind to that serotonin receptor and activate it. Here's an interesting thing too. Here's psilocybin and here's psilocin. So psilocybin is what's in the mushroom, but you can see this big phosphate group here. Something with a big negatively charged group like that won't get into your brain. So psilocybin actually has no effect on your body. But our good old friend, the liver, will take that phosphate off and turn it into psilocin. Now this gets into your brain. So the actual active ingredient in those mushrooms is not active until your body works on it and makes it active. And importantly for this talk, there are a lot of different serotonin receptors. They're called 5-HT receptors, 5-hydroxytryptamine, which is just another name for this structure. So the main ones in your brain are 5-HT1A and 5-HT2A, but then there's, you know, probably a dozen other ones that are scattered around at lower amounts. The one that we're most interested in here is this 5-HT2A subtype. So that's what the psychedelics will activate. Little brain structure here, where I always like to talk about the brain in terms of evolution. So you've heard people say kind of jokingly, your reptilian brain. Your reptilian brain is the most basic part of the brain down here. And here's our Mr. Reptile over here. And that's the brain stem, which is the medulla, medulla oblongata, the pons, and the cerebellum. So these take care of all really basic functions like movement, balance and coordination, and the medulla is involved in the autonomic nervous system. So keeping your heartbeat regular, breathing, regulating your digestion, all this housekeeping stuff that you don't have to think about because your body does. The medulla is doing that. So this is the simplest aspects of your brain, where even fish have this. It's the simplest way to have a brain. And then the middle part here, our mammalian brain, is our emotions. So our emotions are more complex. You know, you may love your chameleon, but your chameleon doesn't love you, I promise. They don't have those kind of emotions. So what emotions are really about is directing your behavior. You know, if you feel good about something, you get a good emotion from something, you'll do it again. You got a bad emotion from something, you'll avoid it. So this part of your brain is all about behavioral modification. And that's why this is the part of the brain that's all involved in addictive drugs. Cocaine, alcohol, heroin, they all really affect this limbic system, and they're addictive for that reason. And then we get into the outer parts of the brain, the more recent neocortex, and you've got, oops, I've got a touchpad here, it's driving me nuts. So this is the most recent part, and this is where the thinking part goes. This is cognition. So this is mainly what we're going to be focusing on today. We'll talk a little bit about the limbic system, how it interacts with your cognition, but mainly we're talking about cognition. Here's our limbic system. This is the only slide on limbic system today. This is what I want to talk about. So the VTA is way back in your brainstem, and it sends projections up into your limbic system. Most important for us is the amygdala, because the amygdala is controlling your emotions. So input comes into your brain, and it goes to your amygdala, and your amygdala decides how you should feel about it. And then nucleus accumbens here was important in my opiate talk, because this is the center of addiction, your nucleus accumbens. But amygdala is what we're talking about here, and emotion. Okay, so here's the VTA is like down here. Is another one of these tracks here that lead up to the rest of the brain. But today we're talking about serotonin. So serotonin is the red one here, raphe nucleus. So the raphe nucleus has got just a little section of cells there that are all together in one spot. And then they all put out axons that go up this medial forebrain bundle and then innervate the whole rest of the brain. So this little spot down here is going to control your mood by sending these axons up to the rest of the brain and releasing serotonin where it's needed. Okay, so now that we know the outer structure of the brain, how does your brain work? So cognition, this is what cognition's all about. You've got two different ways of thinking. And if you think about it, it makes a lot of sense. On the one hand, when you're not focused on a task, you're just kind of thinking crazy thoughts. They call it monkey mind. You're thinking about this, and this thought leads to that thought, and that thought leads to this thought, and this thought leads to this thought. Your mind is just kind of wandering. That's when you're in default mode. So in default mode, you've got you're focusing on your internal cues. You can sense your hunger, you sense if you're thirsty or tired or whatever. And you've got a lot of self-referential thinking here. This default mode is how you define yourself. The default mode go to the back of your brain to get memories of who you are, and in the front of your brain, you'll construct that idea of yourself. And timekeeping is really important here. And we'll see once you take these drugs, there is no time anymore. And that's because you cut this default mode off. Okay, what's most important for us today, though, is this self-referential thinking. Thinking about yourself. Always dangerous thinking about yourself. Okay, the other network over here is task positive network. So when you're in this is what they call the flow state. You know, when you're working on something, you're really focused on your work. You're not thinking about your hunger or your thirst, and you're not thinking about anything except the task in front of you. So this is like, you know, when they say time goes fast when you're having fun, it's because time is controlled by your default mode network. You're in task positive. You're not paying attention to time. If you're bored, time seems to go really, really slow because you're over here in default mode and you're constantly checking in on time. In task positive, you know, you're not thinking about time, and you look up and suddenly it's 3 hours later. So task positive, we like to call it the flow state. It's when you're really focused on your work and you're not thinking about yourself. So
Dr. Slish, before you move on 1 second, we do have a question from Jade and Penny on the emotional brain. You mentioned that the reptiles do not have that emotion. Do all animals lack that emotional brain?
You know, honestly, I was kind of BSing when I said that. I'm that's not my science. I'm sorry.
Got it. No problem.
But I
wanted to make sure we got the question in.
But I've known some chameleons, and none of them are like me. So I'm just assuming
all
it's
right.
me. I don't know. Could it be? It could be me.
Fair enough. Fair enough.
So anyway, so we've got your default mode, mind wandering. Task positive is when you're really focused on something. Then in the middle here, we've got our salience network. The salience network is taking sensory information in. So everything you're experiencing of the world, before it goes to default mode or task positive, it goes to salience. And salience is deciding what's important now. So salience means importance, okay? So what happens is stimuli comes in, and if there's nothing to do, it will send you over to default mode, and you'll just kind of waste time and enjoy yourself. But if the sensory input tells you, you got to deal with this, it'll send you over to task positive and you'll deal with it. I think the best explanation of this is, one time I was coming down the Northway, 87, I'm flying down the Northway, and you know, my mind is wandering all over the place. And you know, when you drive like this, you don't even see things going by you. You're just flying down the highway. And then suddenly I see something in the road. And in less than a second, my mind made all these calculations. It's like, what is it? Can I hit it? Can I straddle it? Do I have to go around it? Is there someone on this side of my car? And what I did was straddle it and go by. And, you know, I'm moving 75, 80 miles an hour. I had less than a second to make that decision. And my task positive network can do that, okay? That's what your task positive network does. And then once that stimulus went away, like there's a problem up there, then my salience network put me back in default mode, and I was listening to the radio again. So that's kind of how this works. Information comes into the salience network, and if it's not a problem, you let your brain relax. But if it comes in and it's something you need to deal with, you'll go over to task positive. Okay, this is like in your brain where your task positive network is. So there's two real nodes, one on each side of your brain. One is the dorsolateral prefrontal cortex, which is right here. So you've got a chunk here and chunk here. And this is the thinking part of your brain that does calculations. So when you're in task positive, you're using this part of your brain. And then back here, a posterior parietal cortex back here, these sections then are storing memories. So you've got memories of how to do things. So, you know, maybe you're a carpenter and and you see what the problem is. There's a wall. I need a wall. Well, how does a wall work? Well, I need studs every 16, and you just go from here to here, and you put your wall together. So you've got memories back here and calculations up here, and that's how you complete tasks. Default mode then is medial prefrontal cortex, so right here. Sometimes they call it orbital prefrontal cortex because it's right behind your eyes. So this whole medial part of your forebrain. This is where the thinking part of you is when you're relaxed. And when you're like thinking thoughts, those thoughts are right here in this section of your brain. And this section of brain goes back to other memory centers. This is your lateral parietal cortex. So this is a little further to the side. So posterior's here, lateral's here. And then right in the middle of your brain are the posterior cingulate cortex and the precuneus. Precuneus is especially important for storing memories of who you are. So your whole history is stored in the precuneus. So when your default mode wants to know who you are, it asks the precuneus and brings information up, and then you calculate it up here, remembering who you are and what's important to you. So that's your sense of self, this connection between this medial prefrontal cortex and the precuneus. That's where you get your sense of self. And that's important. We'll talk about that later. Okay, so what's going on? Medial prefrontal cortex is the cognition, the thinking. PCC are memory and processing. And then these two are your autobiographical memories. Oh, here it is. Medial prefrontal cortex, executive, self-referential thinking, defining yourself as separate from the environment. That's really important. We'll see that today. So when you're sitting down, you know, here's this chair over here. That chair is not me. I'm here, and the chair is over there. Your medial prefrontal cortex is doing that. And it may seem obvious because you've never lost that sense, but we'll see what happens when we take drugs. Okay. So this is not anatomical. This is kind of a graphical way of looking at how your cognition works. Your ACC and insula are your salience network. So information comes into this salience network, and then the salience network decides what to do with it. If it's something important you need to deal with, it'll send it over here, and your task positive mode will deal with it. If it's not important, then you'll go back to default mode and just let your mind wander. It's a lot of work thinking. Thinking's a lot of work. It costs a lot of energy. So if you don't need to deal with something, you're better off relaxing over here. So that's kind of how your brain normally works. Depression. Let's talk about depression. Can I tell you about my depression? No. Depression is basically excessive rumination on negative thoughts. You've got an impaired ability to direct attention outward and perform tasks. Your task performing is your task positive node, right? So rumination is your default mode. Hypersensitive to negative thought initiation. A bad thought will get caught in your head and you can't let go of it. You keep thinking about it and thinking about it and thinking about it. And you can't get out of that cycle. You can't get yourself to do anything purposeful or useful. You're just kind of stuck being depressed. So depression basically is obsession with negative self-referential thoughts. Self-referential, right? Default mode. Patton Oswalt, there's a video embedded in this, which I'm not going to show because videos don't work very well over Skype. But if you get a chance, take a look at Patton Oswalt. I forget what show he's on, but he's talking about his depression. And he's funny as hell, but at the same time, it's really sad when you hear what it's like. The end of it, he's talking about, you know, he went out to get something to eat. He's in the store, staying in front of this big rack of lean cuisine. He picks one up that looks pretty good, and he reads, how do you do it? You heat it up for 3 minutes, and then you stir it. Oh, I can't stir it. What am I, Wolfgang Puck? And he picks up another one. Just heat it up and eat it. Okay, I'll do this one. So it's like he's so depressed, he can't even think about, you know, stirring it. Come on. So that's what depression is like. You just, oh, I just can't do anything today. Let me pause for a second. Dad, I'm online. Depression. Okay. Cognitive disorders. Okay, so why is it that you are in depression? What's different about your cognition? What happens is you've got a weakened salience network, so you can't switch out of default mode, right? Default mode, you think about yourself all the time. And in test positive, you don't. You'd feel a lot better if you could do something, but you can't switch out of it because your salience network is weakened. And you've got a strengthened connection between your amygdala, your emotions, and your default mode. So you end up thinking about being depressed, and being depressed makes, feeling sad makes you depressed, being depressed makes you sad, and you get caught in this loop where you can't really get out of it. All you have is these negative self-referential thoughts, and you can't get out of them. So you're strengthening this connection between the salience network and the default mode, and weakening the connection over here to task positive. And at the same time, you also weaken the connection between the medial prefrontal cortex and the memories of yourself. So all these thoughts you have of yourself, of how bad you are and how horrible your life is, are not necessarily real or true, because you're not accessing your real memories of who you are. This is all just this depressive loop, and it's not realistic. It's just that you're stuck in this. So
There's a question about why is the brain not able to ruminate over positive or happy thoughts?
Oh, it can. It totally can. But that's not depression. I'm just talking about depression here.
Got it. Okay.
And you know, that'll happen. I don't know. I'm going out on a limb here because this isn't something I know a lot about. But that may be part of, you know, bipolar disease. On the upside, you're ruminating on good stuff. On the downside, you're ruminating on bad stuff. Maybe. I don't know. I'm making that up, but it sounds realistic. Okay.
Thank you, Dr.
Oh, sure. Okay, so what do our psychedelics do? Boom, this. Psychedelics cut everything off in your brain. So you're no longer taking this external stimuli going through your salience network. This is where you are. You're all in your medial prefrontal cortex. You're not connected to yourself anymore. You're just thoughts right here in your brain. So we talked about depersonalization and out-of-body experience. You're no longer connected to your memories of yourself. You don't know who you are. Well, if you're not you, who are you? And then you get this sense of oneness with everything. That chair over there is part of me, and I am part of that chair. I am part of the world, and the world is part of me, the spiritual oneness, because you've lost all these connections to all your other memories and things. And this is where that spiritual enlightenment comes from with psychedelics. Okay, so getting into some of the studies people have done with depression, there have been a number of studies, not enough, but there have been a number of published studies where they use psychedelics along with therapy with people who have got either resistant depression that resists all other drugs, or maybe they've just gotten a diagnosis of cancer. You've got 6 months to live. That's got to make you feel pretty depressed. So some of the studies are the cancer studies, and some are just, you know, depression that has no cure. And the way they do this study is first you talk to the psychotherapist for a long time to get yourself prepared for it, and then they put you down they give you the drug, you lay down. You usually block your ears and your eyes. You have music in your ears. And then the psychotherapist is with you there through the whole time to help you through the experience and help you to understand the experience. And then you keep going back to the psychotherapist to kind of integrate the experience with your life in a positive way. So that's how the studies are done. Or that's how the treatment is done. The studies, they try to use controls and things, but we'll talk about why the controls are hard. So anyway, here's one of the first ones that was published in 2011 with advanced stage cancer. So these are people who are really upset because they know they don't have much time left. And they had 12 patients, and what they found was 11 out of the 12 felt better. You know, they felt like, okay, I've got 6 months, I'm going to enjoy the 6 months. I'm not going to be depressed. And 6 months later, if they were still alive, they were still not depressed. And this is the amazing thing about these psychedelics, that, you know, once they break that depressive cycle, it doesn't go away. It lasts a long time. It's not like an antidepressant where the other kinds of antidepressants where you feel good as long as you're taking it, and when you stop taking it, you want to kill yourself. This is one experience, and the depression goes away, and it lasts. Usually, they're doing their studies up to 6 months later, and it lasts that long. Here's another study: 51 cancer patients with life-threatening diagnosis, symptoms of depression or anxiety. And they used low dose and high dose psilocybin. Low dose was supposed to be their control, but it's not the best study for that in that respect. But anyway, with high dose psilocybin, they had decreases in depression and anxiety, increases in the quality of life, meaning of life, optimism, decreases in death anxiety. 6 months later, 80% of the patients still felt good about it. They had improvements in their attitudes about life, mood, relationships, spirituality, and 80% endorsed well-being. Were 80% endorsing well-being, life satisfaction. I think that's a typo. I'm not sure what I mean by endorsing there, but I think you get the general idea. Here's another study: 29 patients with cancer-related anxiety, and I'm not going to go too slow here because I think you're probably getting the gist now. Immediate, substantial, sustained improvements in anxiety and depression. And if you look down here, 60 to 80% of them have these sustained benefits 6 months later. It's like magic. So this is treatment-resistant depression. This guy here is one of my heroes, Robin L. Carhart Harris. He's done a lot of the work on default mode and the parts of the brain involved in default mode. So this study used 12 patients, 6 men, 6 women, moderate to severe, unipolar, meaning not bipolar, treatment-resistant depression. 2 oral doses of psilocybin, a low dose first, and 7 days later, a higher dose in a supportive setting. Okay, so you've got a psychiatrist there helping you. And depressive symptoms markedly reduced in 1 week, and 3 months later still after high dose treatment. Marked reduction in anxiety and anhedonia, lack of joy. Okay, so summary. And there were a couple other studies that I didn't include, but they all show pretty much the same thing. Significant decreases in anxiety and depression, like 80–90% of the people who go through this treatment have decreases in anxiety and depression. And the improvement sustained for at least 6 months. And you can imagine if it started going away, you could do it again every 6 months. It's not a bad experience. And the improvements are always associated with that mystical, spiritual experience that you get from psilocybin, that sense of spiritual oneness with the world. By the way, you get that same experience from meditation. If you get seriously into meditation, it produces the same state as the psychedelic state. Caveats, like what is it about these studies that make you pause a little bit? For one thing, they're all small sample sizes. You hear them talking about how they're going to test the COVID vaccine. They're going to test it on 100,000 people to see if it works. You know, that's a real study. That's a serious study. Here, these sample sizes are between 7 and 50 patients. So sample sizes are really small. Also sample bias. The people who are willing to try this study are people who are willing to do psychedelics, and they know they're getting a psychedelic, so they expect to have a good result from it. That kind of clouds the study too. And there's really no good placebo. There's one of those studies they used niacin as a placebo because I guess it makes you feel a little something. But you know, if you're tripping, you know you're tripping. If you're not tripping, you know you're not tripping. So it's hard to do a good placebo. How is it doing this? How are these psychedelics causing this benefit? What they're doing, like I showed you in that one drawing, they're decreasing connectivity with that default mode. So default mode can be hyper connected to your amygdala during depression, and so by cutting that link, stopping that cycle, it can get you back into a normal way of thinking. So increased amygdala activity in depression, attention to negative environmental social stimuli, and that's blocking out positive information. So that's depression, okay? You're blocking out anything good in your life and focusing on the bad and just thinking about that. So serotonin, an important mechanism of serotonin is it's involved in feedback inhibition of the amygdala. So the front of your brain will say, nah, I don't want to feel bad today, and it'll send serotonin back to your amygdala, tell your amygdala to chill out. So that's one of the things serotonin does. So these drugs are activating that pathway. So psychedelics then act as serotonergic agonists, and they enhance that inhibition of the amygdala, calming the amygdala down, stopping you from feeling crappy. So that's one mechanism. Another mechanism is that the 5-HT2A receptors increase glutamate release. And I talked about that earlier in terms of hallucinogens with your occipital lobe. Glutamate also is been shown to release brain-derived neurotrophic factor. Neurotrophic means changing the brain, basically. So this is how those long-term effects happen. When your brain releases BDNF, you get changes in the axons and dendrites of your neurons, changing your pathways, and you're getting some kind of growth from that. So these psychedelics are causing that to happen, and that's perhaps why they last for 6 months. You have one trip, and then 6 months later, you're still feeling better, and it could have something to do with the release of this neurotrophic factor. So this is just a summary from this reference. So what these things do is can decrease default mode connectivity, which I talked about, which is going to decrease your negative self-referential thoughts, and that makes it an antidepressant and anxiolytic, killing your anxiety. It can also directly block your amygdala, which is decreasing your fear, and that's anxiolytic, and it's also antidepressant. I didn't talk about this. I'm going to skip over it because I don't find that interesting, frankly. Okay. Also, increasing glutamate release, which causes BDNF release, which increases neurogenesis and neuroplasticity. Neurogenesis, making new nerve cells. Neuroplasticity, changing existing nerve cells. And that can give you that long-lasting antidepressant effect. And the one thing I didn't talk about is the spiritual significant thing. This is another important mechanism of the action. And when people get spiritually open like this, it makes them open to talk therapy. So, you know, part of the process is always talking to the psychiatrist while you're doing it. And when they've had this experience, they're more open to it. 87% of the participants say that their increase in life satisfaction is because of this psycho-spiritual experience. And the intensity of the experience is predictive of how long that therapeutic effect is going to last. And they say it creates a window of opportunity for therapy. You know, you open up this person's brain, now you can really talk to them and straighten them out. And some people say it's like inverse post-traumatic stress-like effect. So post-traumatic stress, you've got one really, really bad experience and you're stuck. You know, you'll always have this fear in you because of that experience. This is the opposite. You've got this one good experience and it helps to change you in a positive way. Oh, I guess that's it.
Question time, Dr. Slish. We do have a few here. I'll take a couple, and then Nate, who's also helping me monitor the Q&A, will take a few as well. You talked about the psychedelics and depression. There is a question from Barbara Alcantara. Can psychedelics help the treatment of ADHD?
See, that's not something I've heard. I don't know about that, but I don't think so. It's ADHD is different, yeah.
Okay, thank you, sir.
We also have another question from Jezebel Contras. Why does meditation cause someone to feel oneness?
Well, it's the same kind of a thing. You know, if you've ever meditated, the whole idea of meditation is you sit quietly and block all those thoughts. So a thought comes up, ignore it, let it go away. Another thought comes up, ignore it, go away. So it's practicing the ability to shut off your connection between your medial prefrontal cortex and all those crazy thoughts coming from the back of your head. And so that's what psychedelics are doing, just boom, chemically shutting it off. But with meditation, you're training your mind to shut off in that way.
All right.
Thank you, Doctor. A question from Addison, who is studying biochemistry at CUNY Baruch, asking about following many scientists who are studying this particular area, and do you have any insights or tips for them on pursuing this sort of research legally with such tight restrictions and stigmas?
Yeah, you know, that's not my field of research. So that's not something I get involved in. I mostly I'm a popularizer, kind of like Carl Sagan. I'm not doing any research in this area.
Okay, thank you.
Should we
Let's see.
pose more questions?
Sure.
All right.
So,
We
Dr.
have
Slish, okay?
Sure.
we have a question from John saying that, is there any evidence that these benefits have influenced whole groups of people? The benefits you mentioned with of long-lasting psychedelic-induced that's a different one. More questions came, so the entire list shifted out as I was reading it.
No, I got the question. Yeah, I'm not really sure about. I think probably an anthropologist would know more about that than me. Because these things have been used that way by shaman for centuries. But in terms of modern day use of these in that sense, no, I don't know of anything like that.
Okay.
Thank you.
There
Another
is
question here, doctors. Oh, go ahead.
Interject for 1 second. There is a theory which I don't necessarily subscribe to, but it's called I think it's called the psychedelic ape theory, which is that there's a pretty well-established cognitive leap that happened in our species about 75,000 years ago, and the theory is that humans found psychedelics and that expanded their minds, and that was where this leap came from. I don't know if I necessarily believe it, but look into that psychedelic ape theory.
Interesting. All right. Another question, if used long-term in patients, would you see, or is it anticipated that there be a tolerance to psilocybin or a decrease in the effect with serotonin?
Well, there's definitely a tolerance that builds up, and that's why people don't, do LSD every day, because it stops working after a while. But in terms of therapy, that's not the way it would be done. It would be done once, and then with therapy, and then 6 months or a year later, you need another episode, then you do it again. But you're not going to get tolerance using it that infrequently. You would have to use it every day to get tolerance.
Renee Arnold is asking, has there been a study similar to with depression? Has there been a study conducted using psilocybin to help veterans with PTSD?
Not psilocybin. I've heard there's been work with MDMA and PTSD. MDMA is also a serotonin releaser, but it activates all serotonin receptors, and it ends up releasing oxytocin, which is the love drug. It makes you feel comfortable, relaxed, and happy. And from what I've heard, that's mainly what they're experimenting with PTSD.
Thank you. That other question that Nate was alluding to before, I think there's a little more to the thread here. The benefits over whole groups, aside from the Vermont example, perhaps, in societies where, no, not at all. In societies where drugs or certain drugs are legalized, example, people in the Netherlands as compared to the United States or other countries where drugs are more legal or more accepted, and has anyone measured those particular differences?
That's a really good question. I think that would be better, though, for a sociologist than me. I'm more about the molecular mechanisms of things, but that's a really good question. I'd like to see the answer to that.
Right. Thank you. I'm just scrolling here. Nate, I'm not sure. Go ahead, Nate.
Who did you want? Who's okay? Let's do the one that's up on the top.
Sure.
Anonymous attendee said, "Are you able to speak about potential long-lasting psychedelic-induced psychosis / schizophrenia? Is this true, particularly if genetically predisposed?"
Exactly. It's about the predisposed, and I write about this in my book a little bit. Most people are not going to have that. It's not like everyone who takes LSD goes crazy, but if you're predisposed, this release of glutamate can induce some glutamate toxicity. So then neurons die back, and that's where you get your psychosis from. So typically what it is someone's kind of close to the barrier. They're normal, but they're right on the edge, and then boom, they tip underneath it by using this. And so I would say you're most in danger from youth until your late 20s. where your brain is all developed and you're not changing anymore. So in that period, that's usually where, you're like during that period, you're pruning back neurons. So you're killing neurons that aren't important. And that's what maturing is all about. And if you're adding more stimulation to that dying back and you're someone who's on the edge anyway, that's where it happens. And that's why during that pruning process, that's why people who are schizophrenic, typically symptoms show up in the 20s. So that's the dangerous area.
Okay, thank you.
Thank you.
Leonardo Vando asked, has a question regarding microdosing. And what do you think of the new trend in microdosing? Also, any other effects of 5-HT2A?
Yeah. Wow, I don't know anything about that. All I know is probably what you know from hearing about it in the media. It sounds like, I think Google runs on microdosing, or some of these. I've heard some of these tech companies in California, they're all doing it. I don't know anything about it though. Sorry.
All right, thank you. Let's see. Do you see any changes in Controlled Substance Act that will come in the near future that would more accurately describe the safety of these drugs?
Well, I hope so. I mean, we're now seeing, legalization of marijuana, which was Schedule 1, is still Schedule 1, and it's not a dangerous drug at all. So we've got a little more rationality about marijuana. I think probably these psychedelics will become available to doctors anyway, eventually, if enough of this evidence of effectiveness it gets put out there. It will probably be brought down to like a Schedule 2 where doctors can use it. I don't think it's ever going to be over the counter where you can just buy it, because they're still pretty dangerous drugs if you're not doing it correctly.
Okay. Another question, are you aware of any more recent current clinical trial variants being run with psychedelics? Are these drugs being used as a standard of care for depression yet?
Oh, definitely not a standard of care. It's still pretty experimental. But in terms of recent studies, the most recent I saw was 2018. I imagine the studies are going on now. Maybe, hopefully, they've expanded to larger patient sizes or group sizes. But yeah, the last published thing I think was in 2018. Hopefully, they're still working on it though. But again, it's like it won't be accepted therapy for at least 20 years, I would get, 10, 15, 20 years, if it ever is.
Don, can I interrupt on something with that? This is Shelley again. Is all of this still happening kind of like the therapeutic use of psychedelics? This is all happening kind of off the radar still, right? Because there's like my understanding was there was kind of like this like subculture that people would find out, hey, you can go to so-and-so and get this therapy, but it's not really, because of the Controlled Substance Act, they can't really advertise.
Right. Yeah, if you've read the book, Michael Pollan's book, what is it now? I can't remember, To Change Your Mind or something like that. That's what he did. He found, people who are just helping other people by giving them trips, but you have to know somebody who knows somebody, basically. In terms of clinical medicine, it's not accepted yet, but it's never stopped. When it was made illegal, it's not like it's stopped, because a lot of people get benefit from it, and they're just going to keep it going. Yeah.
Thank you, Dr. Slish. There were just some comments, even not questions. This is very helpful, valuable information, and thank you for your time. Shelley, I don't know if you have any other questions to pose or to follow up on Dr. Slish.
Nope.
Otherwise, I'll invite Dorothy back on to close out our program.
Nope, that's fine. I just want to thank him again for coming.
Oh, sure.
Wonderful.
I love SUNY Orange. I'm the biggest SUNY Orange fan.
That sounds good to us. We're going to tell our president that. But thank you very much again for coming. And also